second application of the dimensional analysis to check the dimensional correctness of the given physical equation. In physics, we will derive the number of the physical relations. Whether that is dimensionally correct or not, that also can be easily checked by this example. For example, we have derived the equation for the time period of a simple pendulum T is equal to 2 pi root of L by G. Whether this is dimensionally correct or not, easily we can verify. And again, according to the principle of homogeneity, left side time period is there, so right side also must be time period. Why? Because the physical quantities having the same dimension always must be compared. Now in LHS, time period is there, so dimensional formula is T. In RHS, you have 2 pi. 2 pi is the just a constant, it does not have any dimensional formula. Root L, L is the length, so dimensional formula is L. G, acceleration due to gravity, Lt power minus 2. Now from this you will get L square, LL will be gets cancelled, simply you will get T square. Root of T square is equal to nothing but T. Now equation 1, equation 2, LHS is equal to RHS, that is the given equation is dimensionally correct. Next we go through the one more example. Here a gas bubble from an explosion underwater oscillates with a period proportional to P power A, rho power B and E power C, where P is the static pressure, rho is the density of the water and E is the total energy of the explosion. Here we are going to be find out the values of A, B, C. And according to this problem, the period of this bubble is going to be proportional to what? P power A, rho power B and E power C. So time period is proportional to P power A, rho power B, E power C. Now when you remove the proportional, you will get the one constant, some constant decay. And what is the dimensional formula of the pressure, where P is equal to static pressure? Already you know, ml minus 1 T power minus 2 power A. And next to what? Rho, density. Density dimensional formula ml power minus 3 power B. And next E. E need total energy energy dimensional formula ml square T power minus 2 power C. To find out the values of A, B and C, simple we have to compare the powers of the M, L, T both sides. Here M is not there, so that is M power 0, L power 0, T power 1. Now compare the powers of the M. Powers of the M, left hand side 0, right hand side M power A plus M power B plus M power C. A plus B plus C is equal to 0. And the second relation will come as this is 0 is equal to minus A, this is minus 3B and this is plus 2C. And the third relation you will get by comparing the powers of the time period. This is 1 is equal to, this is minus 2A and this is nothing is there, and this is what? Minus 2C. Minus 2C. And from this you can get this as A plus C is equal to, you will get minus 1 by 2. Say this is the equation 1, this is the equation 2 and this is the equation 3. Now substituting the third equation in the equation number 1. Equation number 1 is what? A plus B plus C is equal to 0. A plus C is equal to minus 1 by 2, that is B is equal to, you will get 1 by 2. And similarly we have to get the values of A and C. How to get the values of A and C? Now from the first equation we have to get the value of A and B. How to get the value of A and B? From the first equation we can write A plus B plus C is equal to 0, and from the second equation we can get minus A minus 3B plus 2C is equal to 0. Now adding these two equations, simply we can get this will be gets cancelled, this will get minus 2B, this is equal to, will get plus 3C is equal to 0, that is 3C is equal to, will get 2B, 3C is equal to, B means 1 by 2, that is 2 into 1 by 2 gives rise C is equal to 1 by 3. And when you know the value of B and also C, easily can find out the value of A. So from the third relation you can get A plus C is equal to minus 1 by 2, that is A is equal to, you will get minus 1 by 2 minus C, that is A is equal to, you will get minus 1 by 2 minus C means 1 by 3, that is equal to 6, this is equal to minus 3, this is equal to minus 2, that is A is equal to, you will get minus 5 by 6. Now the values of A comma B comma C are, A is equal to, you got minus 5 by 6, B is equal to, you got 1 by 2, and C is equal to, you got 1 by 3. So like that we can make the use of the dimension analysis while finding the different relations also. This is the third example we have. Now again let us check the relation. This is the velocity of the transverse wave in a steel bar. Here y is equal to Young's modulus, alpha is equal to coefficient of linear expansion of the steel bar, theta is equal to difference of the temperature, rho is equal to density of the steel bar. Let us see whether this equation is dimensionally correct or not. And again here left hand side velocity is there, velocity dimensional formula మనకు తెలిసిందే LT minus 1 RHS under root of y alpha theta by rho. Young's modulus dimension formula మనకు తెలిసిందే ఎలాస్టిక్ కాన్స్టెంట్, ప్రెజర్, వీటన్నిటి కూడా ఒకే రకమైన డైమెన్షనల్ ఫార్ములా ఉంటుంది. ml minus 1 t power minus 2, ml minus 1 t power minus 2, and coefficient of linear expansion alpha, ఇది మనకు యూనిట్ మనకు తెలిసిందే per Kelvin. So alpha dimensional formula is what? K inverse. Temperature dimensional formula is K by density dimensional formula. Density is nothing but mass by volume, m by L cube, that is m L power minus 3, m L power minus 3. Mass will be gets cancelled. This is L power minus 3 goes up, will become L square. K inverse K gets cancelled. This will become T power minus 2. Final ga manaku vachedi LT minus 1. When you remove the square root, you will get LT minus 1. This is the equation number 1. This is the equation number 2. That is, the dimensions of LHS is equal to the dimensions of RHS. So this is dimensionally correct. So this is the second usage of the dimensional analysis, checking the dimensional correctness of a given physical equation. Next we go through the third usage. The third usage, that is to determine the new relations. Here experimentally it was observed that the velocity of the sound in the media will be depends upon the modulus of velocity E and also density of the medium. Now we have to get the relation between the velocity of the sound, modulus of velocity, and also this density. How? So as experimentally observed, the velocity of the sound will be depends upon elastic constant of the media and also density. But to what powers it will be depend, it was not clear. So let us see or let us hope that this velocity of the sound will be depends upon elastic constant to the power A and density to the power B. Now, using this dimension analysis, easily we can get the relation between these three physical quantities. How? If you remove the proportional, you will get the one constant k, that is e power A and also rho power B. And according to the principle of homogeneity, left hand side velocity is there. So, right hand also must be the dimensions of the velocity. So, velocity dimensional formula already know, LT inverse. The physical constant, some of the physical constants actually will have the dimensions, and here A is equal to, you will get 1 by 2, as B is equal to minus A, here B is equal to, you will get minus 1 by 2, and if you substitute these two values in this equation, the velocity of the sound in the media you will get as k into e power A means 1 by 2 and rho power B is equal to minus 1 by 2, or velocity is equal to k root of E by rho. So, k value whatever may be proportionality constant is there, that only can be determined experimentally. This dimension analysis will not be useful while finding the values of the proportionality constant, and experimentally this value is equal to 1. Then the equation for the velocity of the sound in the media is equal to, you will get V is equal to root of E by rho, and like that we can derive the physical relations among the different physical quantities. Now, let us solve the two problems here. What is the dimensional formula of that physical relation R root C by L? What it will be represented? That is the one problem. And here one more problem, here we are given xt, the position of a particle can be represented as V naught by A into 1 minus e power minus at, where x is the position of the particle and t is the time. Here V naught and A are the constants. And what are the dimensions of or dimensional formula of V naught and A? This we have to find out. First of all, let us check this relation. What physical quantity will be given by this relation? How? So, whenever you take the r inside, simply you will get this equation as r square c by L. Okay. And next, you know that the unit of the resistance is equal to ohm, that is r square ohm into ohm, into capacity is equal to, already know, Q by V, that is charge by potential, and let me write in the formula like that. And the unit of this inductance is equal to, already know, ohm second. Now ohm will be gets cancelled. Now in the next step you can get as ohm by second into charge by potential is equal to, simply we can write V is equal to IR. IR is nothing but what? I means ampere, resistance is ohm. So you will get ohm will be gets cancelled. Now charge by time is nothing but what? Current. Current by current is equal to, simply you will get what means no dimensions. So like that easily we can get the dimensional formula of R root C by L. Now come to this equation. So it is dimensionless. Now come to this equation. Here x is represented as the position. Position means say distance. So now again, according to the principle of homogeneity, left side distance is there, means right side also must be distance is there. And however, this is V naught by A definitely will be equal to the Ex. Why? Because this is dimensionless. And moreover, the power of exponential here, At, also should be dimensionless. So as At should be dimensionless, M0, L0, T power 0. Now the dimensions of A simply you will get as T inverse. Now according to the principle of homogeneity, the dimensions of x must be is equal to nothing but V naught by A. So the dimension of the position is equal to L. Now V naught, the dimension of A is equal to, already we got that, is equal to T inverse. Now the dimensions of V naught is simply can be written as V naught is equal to LT inverse. So like that easily we can find out the dimensions of V naught and A, and also the which physical quantity will be represented by that relation. Easily we can find out by using the dimensional analysis. Now let me take one more problem here. The torque acting on a particle is represented by this relation, which is equal to KL plus xi by omega. Here K is equal to constant, L is equal to angular momentum, x is equal to constant, I is equal to moment of inertia, omega is equal to angular speed. Here we require to find out the dimensions of Kx, or the dimensional formula of Kx. How? And again, according to the principle of homogeneity, these two relations are actually equated. So the dimensions of torque must be is equal to nothing but the dimensions of KL as well as the dimension of xi by omega. So how we can write that one? Torque is equal to simply KL. Instead of substituting directly the dimensions of torque and also angular momentum, let us get like this. Torque is equal to, already know, rate of change of angular momentum, K into L. So angular momentum dimensions will be get cancelled, and simply the dimensions of K is equal to, you will get T inverse. Now let us find out the dimensions of what? X. Torque tau is equal to, now we can get xi by omega. And simply we can use the relation again. Torque tau is equal to what? Means I alpha is equal to xi by omega. I will be gets cancelled. Then x is equal to nothing but alpha into omega. Alpha is equal to, again you know that rate of change of angular velocity, omega by t into omega, that is equal to omega square by t. Omega dimensional formula already you know, t minus t inverse 1, t inverse, that is whole square is there, so square by t, that is equal to, you will get t power minus 3. This is the dimensional formula of x. Now you are asked what is the dimensional formula of kx. Kx is equal to nothing but k, already we got t inverse, and x is equal to, we got t power minus 3, and lastly you will get t power minus 4 is the dimensional formula of kx. So like this we can make use of the dimensional analysis for getting the dimensions of the different physical quantities. Next we go through the topic errors. What is the error? Error is nothing but it is the difference between the measured value and also actual value, nothing but true value. Measured value minus true value, this is simply can be called as the error, or true value minus measured value, whatever it may be, simply that can be called as the error. Already you have studied in regular classes types of errors. What are the types of the errors? You know that systematic errors, random errors, and third one is gross errors. Systematic errors, the errors which will be follow the irregular rule and which will be present in every measurement, or simply can be called as the systematic errors. For example, constant error, instrumental error, personal errors will becomes under the systematic errors. Random errors, whose causes are not known. Are called as the random errors. And the last one is gross errors. Gross errors are mainly due to the observer defect, observer carelessness, which leads the gross errors in the measurement like that. These are the types of the errors. Here important error is actually called as a least count error. What is a least count error? What is a least count? It is the minimum value that can be determined by using any instrument. What does that mean? For example, I am going to use a scale here to determine the length of a rod. Say this is 0, this is 1 centimeter, 2 centimeter. When I am going to find out the length of the rod, if you observe carefully, here the length of the rod you are going to be get about 1.4 millimeter, but not exactly. The reading is lies in between this division and also this division. That means in this measurement you are going to be get a error about how much means 1 millimeter. The minimum value that can be measured by using an instrument is actually called as a least count. So the least count of the scale is equal to nothing but 1 millimeter, and hence in this measurement always error of 1 millimeter will be present. That means I can write this equation, this value as 1.4 millimeter plus or minus 0.1 millimeter, 0.1 centimeter, or simply can be written as 1 millimeter. This is called as a least count error. In the place of the scale, if you use the, for example, a vernier calipers, usually in the vernier calipers, the vernier scale will have 10 divisions, and hence its least count you will get about 0.01 centimeter, or you can call 0.1 millimeter. Now the error will be presented in the reading of the a body by taking the with help of the vernier calipers always will be 0.01 centimeter. For example, if I find out the length of a rod as 4.54 centimeter like that, in that error will be present is equal to, you will get plus or minus 0.01 centimeter. This error is actually called as the least count error, which is very important while solving the problems. It will be very useful to us, that we discuss when the problems will be comes. Next we discuss the true value. What is the true value? Actually, whenever we measure the length of a rod like that, we will not happy with the one single measurement. In order to get the accurate value or the true value of the length of the rod like that, what we do here, we will take the several readings. Say I have taken the readings as x1, x2, x3, x4, x5 and so on. So what will become the true reading of the rod or the true length of the rod? That is nothing but the average value of all these readings, x1 plus x2 plus x3 plus and so on by the number of the measurements, this x mean. This x mean value simply can be called as the true value. This is the true value, and next we will get error. What is the error? Now error is nothing but, you see, whenever among all these measurements x mean will become the true value, then error is equal to is nothing but it is the difference between the measured value and also mean value. X1 minus x mean. This will simply can be called as the error. And what is the next error you will get? For the second measurement, x2 minus x mean is equal to another error. Say this is equal to delta x1, say this is equal to delta x2 and so on. Now next, what is the absolute error? The magnitude of the difference of measured value and also mean value is simply can be called as the absolute error. Absolute error is equal to is nothing but the magnitude of measured value and minus x mean value, delta x. Look this carefully. Here we are going to be get the error is always what? Positive. So absolute error is always can be positive. but whenever you take the error may be positive or negative. For example, if the true value is equal to 2.54 centimeter and the measured value is equal to 2.52 centimeter, and the difference between the measured value and also true value will get minus 0.02, or the difference between this true value and also this measured value is equal to plus 0.02. Say this is actually positive error. If I take the measurement of the quantity as 2.56 centimeter like that, now the difference is equal to, you will get minus 0.02 centimeter. That means the error may be either you can get positive or negative, but while finding the absolute error, always we have to take the magnitude of the error. So automatically the value will become positive. This is called as the absolute error. After this, mean absolute error. It is very simple. The mean value of the all absolute errors can be simply called as the mean absolute error. And the next, relative error. Simply it is a ratio of mean absolute error to the mean value, or you can say true value. And the next one is percentage error. Percentage error is nothing but relative error into 100. This will give the percentage error. Combination of the errors or propagation of the errors. Actually, while measuring a physical quantity, for example, we are going to find out the acceleration due to gravity in the simple pendulum experiment while measuring the length of the simple pendulum and also time period of the simple pendulum. Now, whenever we measure these two and the next acceleration due to gravity, if any error is present in the determining the L value and also T value, that will be incorporated in the acceleration due to gravity value also. So, at the time we must know how the errors will be propagated. So, for that purpose we are going to discuss here propagation of the errors or the combination of the errors. In addition process, how it will be propagated. For example, we are going to be measure a physical quantity by just measuring the two other physical quantities A and B. With the addition of this one, you are going to be get the physical quantity Y here. Now, to find out the Y value, first of all we have to measure the A and also then B. So, in measuring the A, the error, absolute error present is equal to delta A, and measuring B, delta B plus or minus delta B. Then whenever these two values are measured and the next this Y value, from this to this Y value, then in the measurement of Y also some error will be present. That error like this, Y plus or minus delta Y is equal to, we can write A plus or minus delta A plus B plus or minus delta B. That is A plus B plus or minus delta A plus delta B. That is Y plus or minus delta Y. So, what you have to understand here, the absolute error in the measurement of the Y is equal to is nothing but delta A plus delta B. This is the maximum possible error. This is called as a maximum possible error in determining the Y. And similarly, in the subtraction also, say Y is equal to A minus B. Now, this is again can be written as Y plus or minus delta Y is equal to nothing but A plus or minus delta A minus B plus or minus delta B. And finally, we can write this is as A minus B plus or minus delta A plus delta B. Don't call this is as delta A minus delta B. Why? Because always the maximum absolute error will be in positive. So, delta A plus delta B. This is in subtraction. Similarly, we can find out in division and also multiplication. In division, say Y is equal to, for example, A by B. In finding the absolute error in the measurement of the Y like that, this method will be followed like this. Take logarithms both sides. Log Y is equal to, we can write logarithm of A by B. So, we will get log Y is equal to nothing but log A minus log B. Now, this can be if you differentiate this one, you will get delta y by y is equal to delta a by a minus delta b by b. But already we discussed that the maximum error will be always positive, and hence this can be written as delta y by y is equal to delta a by a plus delta b by b. So this is already we know the relative error. Then what is the absolute error in measurement of the y means simply we can write delta a by a plus delta b by b into y. This gives the absolute error in the measurement of the y. And of course from this we can find out the percentage of error also, that is delta y by y into 100 is equal to delta a by a plus delta b by b into 100. And similarly in multiplication also you will get in the same way. In the multiplication also you will get y is equal to, say for example, ab, then take log both sides, then this will become log a plus log b, differentiate this one, delta y by y is equal to, you will get delta a by a plus delta b by b, and again this is the relative error in the measurement of the y, and from this you can find out the absolute error in measuring the y, as well as we can find out the percentage error also. The combination of the errors in the case of a quantity raised to different powers. Say for example, y is equal to some some constant k into some a power n. Here to determine the y, we require to determine the value of the a. We require to measure the value of a. Then how the error will be propagated into y? Simply again by taking the logarithms both side, log y, this is log of k a power n, this is can be written as log k plus log a power n, nothing but log k plus n log a, this is log y. And again by differentiating this we can get delta y by y is equal to, this already we assumed as the constant, this is constant, so constant differentiation is equal to 0. Then you will get this is n delta a by a. So this is the fractional error or relative error that is present in the measurement of the y. And the one of the important thing you have to remember here, that if you do not measure this a accurately, then the value of y will be affected. How? For example, you see delta y by y is equal to, we got n into delta a by a. If you find out the delta a by a with a error percentage, for example 2%, if the power is equal to 3, then 3 into 2% is equal to, simply will become 6%. Say for example delta a is measured as with a error percentage 5%. Then the measurement of y will become the 3 into 5 is equal to, you will get 15%. That is, it will be affected very highly, as a is the power of n like this. So in a given relation, whenever you are going to be measure those physical quantities which are having the powers, that must be determined very accurately. For example, let us discuss one physical relation here. Eta is equal to, relation pi p r power 4 by 8 lv. Here eta is equal to coefficient of viscosity, p is equal to pressure difference, r is equal to radius of the capillary tube, L is equal to length of the capillary tube, V is equal to rate of flow. Or whenever we are going to find out the rate of flow, pi p r power 4 by 8 L into eta. Now in determining the V value, we have to measure the coefficient of viscosity, length of the capillary tube, pressure difference, and also radius of the capillary tube. Among these values, which has to be measured very accurately, if you are asked, then you have to say the radius of the capillary tube. Why? Because this power is 4. So if it is not measured accurately, then the error will be incorporated 4 times. So that care should be taken while measuring the different physical quantities when they are raised to certain powers. For example, y is measured as with a power a and b power b and c power c like this with this equation. Then how to find out the relative error or percentage error in measuring of y? Simply, as we have discussed previously different kind of the propagation of the errors, this can be simply written as delta y by y into a, delta a by a plus b into delta b by b plus c into delta c by c. Using this relation, easily we can find out the relative error in measuring the y and also the percentage error in measuring the y. We will solve the few problems basing on this error concept. For example, say the radius of the earth is shrinked by 2% without changing in the mass of the earth. Then how the acceleration due to gravity on the surface of the earth will be affected? This is the question. So here he was told that radius is going to be changed by 2%. Shrink means it is decreasing by 2%. Then how the acceleration due to gravity on the surface of the earth will be affected? So you know the formula, G is equal to capital G capital M by R square. That means to find out this G value, we require to measure the mass of the earth and also radius of the earth. In the problem it was told that without changing the mass of the earth, so no need to measure the mass here, and G only will be inversely proportional to the square of the radius. So we already discussed the propagation of the errors in the divisions. As G is inversely proportional to 1 by R square, we can write delta G by G is equal to minus 2 delta R by R. Of course, what is the use of the minus n? Just now we come to understand. Now it was already told that radius is decreased by 2%. Then when you convert this in the percentage error, that is minus 2 into delta R by R into 100. So this is given already 2%. So minus 2 into 2 is equal to, will get minus 4%. This is the percentage of the change in the acceleration due to gravity on the surface of the earth. What is the importance of the minus here? Here you see the acceleration due to gravity will be inversely proportional to the radius of the earth. That means if the radius decreases, acceleration due to gravity increases, or if the radius increases, the acceleration due to gravity will be decreases. And already given that delta R by R into 100 is equal to 2% decreased. If I write here this is equal to minus 2, then simply this will become the what? Plus 4%. It indicates that when the radius is decreased, acceleration due to gravity will be what happens? Increases by the 4%. And do remember, this kind of the method cannot be used everywhere or every time. Why? Because here the percentage of the error only we are taking 2% or 3% like that. Whenever the percentage of change will be more than the 10, 12, 13, 20, 25, 30 like that, then we cannot use this kind of the method. At the time we have to go the direct method. How to go to the direct method? Let us discuss that one by taking the one example and how that will be deviate from this method. For example, the time period of a simple pendulum already you know T is equal to 2 pi root of L by G. Say the length of the pendulum is changed by only 1% changed. Then by what percentage time period of the simple pendulum will be changes? That is the question. Then as the percentage of change in the length is very small, we can apply easily the direct errors method. T is proportional to root L, nothing but T is proportional to L power half, that is delta T by T is equal to, you will get 1 by 2 delta L by L. When I take in the percentage, directly I will get delta T by T into 100 is equal to 1 by 2 into delta L by L into 100, that is 1 by 2 into already 1% is given to you. So the time period of the simple pendulum will be changes by 0.5%. Say I have given like this, the length of the simple pendulum is increased by 21%. Then how the time period of the simple pendulum will be changes? Now see the difference of using this method and also that the direct formula method. Here if you use for example this method, t is proportional to root L, then delta t by t is equal to, will get 1 by 2 into delta L by L, then delta t by t is into 100 is equal to, you will get 1 by 2 into delta L by L into 100, that is 1 by 2 into delta L by L into 100 is equal to given 21 percentage, that is equal to, you will get a 10.5 percentage change in the measurement of the time period. This is actually not true. Whenever the percentage of the change is actually given larger values, then you have to use the direct formula method. T is proportional to root L, that is T2 by T1 is equal to, you have to write L2 by L1. Here final length is given how much? 21 percentage increased. 21 percentage increased means L2 is equal to 121 by 100 into L1. Then what do you get? T2 by T1 is equal to, you will get root 121 L1 by 100 into L1, that is T2 by T1 is equal to, you will get 11 by 10. Root 121 is equal to 11, root 100 is equal to 10, that is T2 is equal to, you will get 11 T1 by 10. Then how to get the percentage of change in the time period? That is nothing but T2 minus T1 by T1 into 100. That is from this relation T2 by T1 is equal to, you will get 11 by 10. T2 by T1 minus 1 is equal to 11 by 10 minus 1. T2 minus T1 by T1 into 100 is equal to 1 by 10 into 100. That is equal to, only you will get how much percentage? 10 percentage. You look at the difference between the using of this one and also using of this one. So always what you have to think is, whenever the percentage of change is very smaller values, then only you have to approach this errors method, but whenever the variations are very large, better to follow this method. This directly we can get by using this relation itself only. You see T2 is equal to 1.1 into T1, that is T2 is equal to n times to the T1. Then simply using a shortcut method, 1.1 subtraction 1 into 100, that is equal to, you will get 10 percentage. Also you can write directly without following all these steps. Say for example T2 is equal to 3T1, then how much percentage it is increased? Simply subtract 1 from this 3, that is equal to 2, multiply with the 100, that is equal to 200. It is true in any case. Say for example T2 is equal to 0.5 into T1. So what you have to write? 0.5 minus 1, that is equal to minus 0.5 into 100, that is equal to minus 50 percentage. Minus sign indicates that it will be decreased by 50 percentage. So like that we can use the errors, percentage of the errors in different measurements. Let us solve the few problems based on the errors. Here given that error in the measurement of the radius of the sphere is 1%. Find the error in the measurement of the volume. And of course we can find out the error in the measurement of the area, that is surface area also. How? According to this, given is that percentage of the error in the measurement of the radius is equal to given 1%. Delta R by R into 100 is equal to given 1%. Then what is the formula for the volume of the sphere? V is equal to 4 by 3 pi R cube. But as I said previously to you, it is better to observe this whether the percentage of the change is smaller value or bigger value. Smaller value 1%. So you follow the regular method, errors method. So V is directly proportional to the cube of the radius. We already discussed in the propagation of the errors. When this is raised to certain power, then the relative error simply can be written as delta V by V is equal to 3 into delta R by R. So I will write this is as delta V by V into 100 is equal to is nothing but 3 into delta R by R into 100. That is equal to 3 into delta R by R into 100 is equal to 1%, that is 3%. So, you observe carefully here, if the percentage of error in the measurement of the radius is 1%, as the radius power 3 is the value, now volume is going to be affected by n time, that is 3 times, that is 3%. That means utmost care taken while measuring the radius here. And next I also tell about the area, percentage of the error in the measurement of the area also. Area of the surface of the sphere, already we know formula, A is equal to 4 pi r square, and however here again A is directly proportional to the r square, that is delta A by A into 100 is equal to, you will get 2 into delta R by R into 100. This is already given to you 1%, 2 into 1 is equal to, you will get 2%. So, like this we can find out the percentage of the error in the measurement of the value as well as in the area. Let us solve one more problem based on this. Here we go, a next problem. An experiment measures the quantities A, B, C and then X calculated by the relation X is equal to AB square by C cube. If the percentage errors in A, B, C are given plus or minus 1%, 3% and 2% respectively, find the maximum percentage error in measuring X. We already given that X is equal to here AB square by C cube. In the propagation of the errors, already we have studied that delta X by X is equal to is nothing but delta A by A, 2 into delta B by B plus 3 into delta C by C. Now, taking the percentage, that is delta X by X into 100 is equal to delta A by A into 100 plus 2 into delta B by B into 100 plus 3 into delta C by C into 100. From the given problem, the percentage of error in measuring A is equal to given 1% plus in B is given as 3%, that is 2 into 3 plus in C is given as 2%, that is equal to 1 plus 6 plus 6, that is equal to, you will get 13%. This is the value of the percentage error in measuring the X. Delta X by X into 100 is equal to 13%. Here, two resistor of resistances, R1 is equal to given and also R2 is given to you. These are connected in series combination and also next in parallel combination. What we require to find out here means find the equivalent resistance of the series combination and also parallel combination. Let us do one by one. In series combination, we know that in series combination the resultant resistance R is equal to nothing but R1 plus R2. So, resultant resistance in series combination is equal to, you will get 100 plus 200, that is equal to, you will get 300 ohms, and what error you will get in the measurement of the capital R, that is resultant resistance in series combination. Already we know the propagation of the errors in the addition. So, delta R is equal to nothing but delta R1 plus delta R2, that is delta R is equal to, you will get delta R1 is given to you plus or minus 3 and delta R2 is given plus or minus 4, but you have to use always positive values. So, 3 plus 4, that is equal to, you will get plus or minus 7 ohms. That is, final resultant resistance in series combination can be written as 300 plus or minus 7 ohms. This is the answer in series combination. Now, if you take the parallel combination B, so what is the formula for the resultant resistance in the parallel combination of the resistances? So, that is 1 by R is equal to, 1 by R1 plus 1 by R2. Or I can write this is R is equal to R1 R2 by R1 plus R2. So before finding the delta R value, first of all let us find out the R value, that is R is equal to R1 is given 100 ohms, R2 is given 200 ohms by R1 plus R2, that is equal to 300. So that is equal to, you will get 200 by 3 ohms. Next let us find out the error in the measurement of capital R. So R is equal to, you know, R1 R2 by R1 plus R2. Again we already discussed in the propagation of the errors, this can be written as delta R by R is equal to delta R1 by R1 plus delta R2 by R2 plus delta of R1 plus R2 by R1 plus R2. Delta R1. Delta R1 is given to you 3. R1 is equal to 100 plus delta R2, that is equal to given 4. Next R2, that is equal to 200 plus error in the measurement of R1 plus R2, that is already we got 7 by R1 plus R2, that is equal to 300. Now we require to find out the error in the measurement of the resultant resistance in the parallel combination, that is delta R is equal to, you will get, so let me take here 600 as the LCM, then I will get here 6 3 ja 18 plus 2 3 4 ja 12 plus 2 7 ja 14 into R is equal to, I got here 200 by 3. So finally I will get on simplification of this one 2 3. So this is equal to, you will get 30 plus 14 is equal to, you will get 44 by 3 3 ja, you will get 9 ohms. So finally we can write the resultant resistance in parallel combination as R is equal to 200 by 3 plus R minus 44 by 9 ohms. So like this we can find out the error in the measurement of the resultant resistance in series combination as well as in the parallel combination. Let us solve this last problem in this session. And given that here a physical quantity Q is going to be measured by the relation Q is equal to A square B power 3 by 2 over C power 4 D power half. Now the percentage of error in the measurement of A, B, C, D are given 1%, 2%, 4% and 2%. Then what is the percentage of the error in measurement of the Q? How to get this? Here given that Q is equal to A square B power 3 by 2 by C power 4 D power 1 by 2. Now already we discussed the propagation of the errors. Following that principle we can write delta Q by Q is equal to 2 into delta A by A, power will become, and next here also 3 by 2 into delta B by B plus 4 into delta C by C plus half into delta D by D. Now percentage of errors are given to you. So delta Q by Q into 100 is equal to, we can write 2 into delta A by A into 100 plus 3 by 2 into delta B by B into 100 plus 4 into delta C by C into 100 plus half into delta D by D into 100. 2 into this value is given 1%, that is 2 into 1 plus 3 by 2 into this value is given 2% plus 4 into this value is given 4% plus half into this value is given 2%. So finally you will get this is 2 plus 3 plus 16 plus 1. So finally this will get as 22 percentage. So this is the percentage error in the measurement of the Q like this.